Hello everyone, welcome to EEN 338 tutorial 2. Our first question for this tutorial is, we have rho v equals to 10 over r square milli column per meter cube for r is between 1 and 4, and it will be 0 for r greater than 4. We need to find the flux at r equal 2 and r equal to 6. Also, we need to find the flux density D at r equal 1 and r equal 5. For A, we know that the flux equals to the integration of the flux density ds over the surface, which is also equal to the total charge enclosed by the surface. So at r equal to, we have rho, we have ds, so we can find q, and since q is equal to the flux, so we can use that flux equal to charge, which is equal to the integration of rho v dv over the volume, which will be equaling to triple integration. First one is r, and our r starts from 1, and we need at r equal 2, so it will be from 1 to 2, and the phi is from 0 to 2 pi, and our theta is from 0 to pi. Of rho, we said rho is 10 over r square milli, and our dv is r square sine theta d theta d phi dr. R square will be cancelled with r square. Integration of sine theta d theta from 0 to pi is 2, and integration of d phi from 0 to 2 pi is 2 pi. So we will have 4 pi multiplied by 10 milli multiplied by the integration from 1 to 2 of dr, which is equal to 2 also, which is equal to 1. So our final answer will be 40 pi milli coulomb, and this will be the flux. Now at r equal to 6, we will use the same formula, flux equal to the charge, which is equal to the triple integration. Now here we need at r equal 6, but our rho is only for r from 1 to 4, so our integration will be from 1 to 4 for r, from 0 to 2 pi for phi, and from 0 to pi again for theta. Our rho is 10 over r square milli multiplied by r square sine theta d theta d phi dr. R square will be cancelled with r square, and this integration will equal to 3 multiplied by 4 pi multiplied by 10 milli, which is equal to 120 pi millicoulomb. This is for part A. Now for part B, we need to find the flux density at r equal 1 and r equal 5. Now we said at the beginning that the flux equal to the charge, which is equal to the integration over the surface of d dot ds. Now the integration here of d dot ds is equal to d, which we consider it as constant, integration over the surface of ds, which is equal to d multiplied by 4 by r square. So we can say that q equal to d multiplied by 4 pi r square, and from here we can find that d equals to q over 4 by r square. Now we will use this equation to find d. At r equals to 1, now we said that our rho is for r greater than 1 and less than 4. So at r equal 1, the rho will be 0. And since the rho is 0, the charge will equal to 0. And from here, we can find that the flux density is equal to 0 also. Now at r equal 5, our q equals to the triple integration from 0. Now for r, we said it starts from 1 till 4, and since the r requested here is greater than 4, our limit integration will be from 1 to 4 only. Then phi is from 0 to 2 pi, and theta is from 0 to pi. Rho is 10 over r square milli, and dv is r square sine theta d theta d phi dr. R square will be cancelled with r square, and this integration will be equal to 120 pi millicoulomb. Now we said that d equals to q over 4 pi r square. We found q to be 120 pi millicoulomb, which means by 10 to the power minus 3 over 4 pi multiplied by r here is 5. So it's 5 square, which will be equal to 1.2 millicoulomb per meter square. And by this we found d at r equal 5.